Hiya, Richard here from Past That Science. Now then, here to some would call this the mother of all questions, or is it? Let's have a look. A three-phase star-connected load has three identical impedances. Each impedance has a self-inductance of 32 millihenry and a resistance of 12 ohms. If the line current is 14.7 amps and the supply is 50 hertz, calculate the phase voltage. So a couple of things to kind of note about here. It looks really complicated, but listen to me now, it really isn't. The phase voltage is the voltage that you get between the line conductor, which is here of course, and this fourth wire here, which would be the neutral. Now then, if you was to find this phase voltage here, and all the impedances are equal and all the currents are the same in each of these, then all of those phase voltages would be the same. So all we need to do is work out the phase voltage that's appearing across these two lines, because the others will be the same, and that'll be the question kind of done then. So the process for that, what we need to do is, of course, is try and work out first of all, this is the inductance in Henry. This chap here, that's your Henry value, that's the inductance. So we need to work out what the effect on the current is. In other words, we need to find then the inductive reactance XL in ohms. Once we've found that, we then need to find out what the combined effect of that resistance and the inductance is. So then we need to find the impedance in ohms. Then once we know the impedance, we've got the impedance, we have the current. So what we need to do then is work out what the voltage is, given just a bit of standard Ohm's law. Not too bad. So then let's work out what the inductive reactance is, XL. So we're going to use the formula XL is 2 pi FL. There's no way around it. You're going to have to remember the formula to be able to solve this question. 2 times pi times F times L. And you're going to need your calculator. A couple of things to think about then maybe. Let's have a look at the next stage. Put the figures in. 2 is a constant value, pi is a constant value, 50 hertz is your frequency, and now L, the inductance. It says in the question there that it's 32 millihenry. Now that is 0.032 Henry, or 32 thousandths of a Henry, or 32 times 10 to the minus 3, whichever way that you've been taught in your lessons. But don't forget that is millihenry. You do have to put that right in the equation, otherwise you'll get it wrong. Then once you roll the calculation, the inductive reactance is 10.05 ohms. Try that on your calculator, try and get a figure. You may not come out with the figure exactly like mine. If you used, for example, if you use the pi button on your calculator, you might come out with a slightly different answer. I'll just use 3.142 because I'm using a different calculator that hasn't got pi function. So 3.142 I used. So if you get something that's slightly different to that, as long as it's sort of 10.04 or 10.06, no one's going to complain about that. That's close enough. Let's now work out the impedance, because we found the reactance. Now let's work out the impedance. Again, it's formula based, so you're going to have to remember this formula. Z, the impedance, is the square root of R squared plus XL squared. So we already worked out XL squared. And we need the resistance. So from the question, the resistance is 12 ohms, and then the inductive reactance that we worked out previously. So R squared, that's 12 squared, XL squared is 10.05 squared. Add them together, square root the answer, and you will come out with 15.66 ohms. Now again, if yours is slightly different to that by a decimal point or two, don't worry too much. Again, it's because I used 3.142 as a value of pi and I didn't use the pi function on the calculator. So something around there would be acceptable. Last part. So for the last part then, we found the reactance, we found the impedance, now we just need to find the voltage using Ohm's law. So Ohm's law, you may be kind of aware of V is I times R, but that's for kind of DC circuits. With AC circuits is V is I times Z. Z is the impedance, and Z is the combined effects of all those components that are having an effect on the current. So we have to use the impedance value, which we just worked out anyway. So 14.7 amps is the I value, that's 14.7. Your impedance was 15.66 ohms that we just worked out on the previous slide. So when you work that out, 230.13 volts. Question done, answered, finished. Thanks for watching. Now go past that science.